Today we're going to look at characteristics of a quadratic function, and we're specifically going to focus on finding the axis of symmetry and the vertex. So I want to fill you in. Here's your essential question. I want to fill you in first on some features, some vocabulary about a quadratic function. Okay? So the first thing I want you to know is that the graph of a quadratic function is called a parabola. Oops, that's not focused. It is U-shaped, okay, and we've seen graphs like this before, but it is U-shaped. Notice the graph can open up or it can open down. I also want you to know that the parent quadratic function is called y equals x squared. I'm sorry, it keeps auto-focusing. It's also, remember we talked about with linear functions, there was also a parent linear function. And the reason this is the parent quadratic is because it's the most basic of all of the quadratic functions. Here's some facts about a parabola and its equation, and we're going to explore this further. We're going to see that if the absolute value of a is greater than 1, the graph is going to be narrower than the parent function. If it's in between 0 and 1, it's going to be wider. We're going to talk about more later on that the c value in our quadratic function happens to be the y-intercept. And it obviously makes the graph shift up and down. But again, we're going to explore that more. I also want you to see here that these four words, solutions, roots, zeros, x-intercepts, all mean the same thing. And again, we're going to explore those furthermore. But today what we're going to focus on are the axis of symmetry and the vertex. I do want you to know that parabolas are symmetrical. This is going to be important when we try to graph. The axis of symmetry. So an axis of symmetry, that's our line of symmetry. This is a vertical line that divides the parabola into two symmetrical parts. So when we're talking about, our parabola, if it looks something like this, that axis of symmetry is an imaginary line that goes right through the middle of our parabola. And we can use this as the formula for our axis of symmetry. And I want you to notice that it says x equals. That's because this is a vertical line. And the equations of vertical lines are always x equal. And what's really important too is that that axis of symmetry goes through the vertex. The vertex is on the axis of symmetry, and it's going to be the highest or the lowest point on the graph. Now it says minimum or maximum, but I want to talk a little bit more about that later on, because the minimum or maximum means the y value of the vertex. Okay, so it's not referring to the whole entire vertex. And it says to find the vertex, we can use the axis of symmetry by plugging it in for the x value to find y. So we're going to practice some of those here in just a second. If you'll take this other sheet that we have, I want to just look at a picture of a parabola and kind of fill it in, and so you can kind of see all the different parts. Again, we're going to explore this in more detail later on. So this point right here, this is the top of our graph. That does happen to be our vertex. It does happen to be our vertex. We could also think as part of it as being our maximum, because the graph is opening down. We would consider that a maximum value there for the y. So this dotted line that's going through our parabola, remember that is called our axis of symmetry. Okay. Then we have some points down here. Let's look at this point right here. This point right here, this would be considered an x-intercept. Some other names for those x-intercepts, remember, are on the other foldable. Those are also called solutions, roots, and zeros. And then over here we have another x-intercept. It just so happens that this point as well, it's where our graph is meeting the x and y axis. So we also have a y-intercept there. Okay. And then this remaining bubble, we talked about that the parabola is symmetrical. And so notice on each side of the axis of symmetry, you always have symmetrical points. So these would be considered symmetric points. It says use a highlighter to identify the portion of the graph when the cap was at least 48 feet above the ground. So looking right here, here is 48 feet. At least means that or greater. So we're actually looking at a range, kind of a range on the graph. And it says what was the elapsed time when the cap was at least 48 feet above the ground. So it looks like from 1 second to, what, about 3 seconds? So from 1 to 3 seconds, the cap was in the air. And so we're going to notice that the cap would be, there when it's rising and when it's falling. Okay? Okay, let's look at some examples where we are actually finding the axis of symmetry and the vertex. So here is a quadratic equation. Quadratic function, g of x equals x squared plus 6x plus 5. Notice quadratics have that exponent of 2. They have that highest exponent of 2. That's how we're going to know that it's quadratic. And so the first thing we're going to do is find the axis of symmetry. Remember the formula is x equals negative b over 2a. Now at any point if I'm going too fast, remember pause the video so you can write down what you need to. Let's just go ahead and identify our a, b, and c so we really know. A is 1, b is 6, c is 5. Okay, so we're going to plug in our numbers. X equals negative, because that's part of the formula, negative 6 over 2 times 1. Okay, negative 6 over 2 times 1 is going to end up being negative 3. Now, really important, we talked about that the axis of symmetry is a vertical line, so we have to be writing the equation of a vertical line. You have to tell me x equals negative 3. If you just put negative 3, I'm going to count it wrong. I need an equation of a vertical line. Okay, so that's our axis of symmetry. So now for our vertex, we know that our vertex is on the axis of symmetry. So we can take this value that we got for our axis of symmetry and we can plug it back into our equation for x. So I'm going to say negative 3 squared, notice I put that in parentheses, plus 6 times negative 3 plus 5. Now you can absolutely use your calculator for this. I'm going to try to do as much as I can by hand. This would be 9 minus 18 plus 5. That would be negative 9 plus 5, which is negative 4. So my vertex, remember your vertex is a point, is negative 3, because that was the x value, comma negative 4. That is the y value. So there is our vertex. There is our axis of symmetry. Okay, let's do another one. Do one that's a little bit harder maybe. I'm going to do y equals 3x squared plus 2x. Okay, my a value is 3, my b value is 2, and my c value is 0. It's kind of irrelevant for finding the axis of symmetry. We don't really need it, but it's important to know. Okay, so we're going to say x equals negative b over 2a. So negative 2 over 2 times a, negative 2, 6, which is negative 1/3. Now, really important, 1/3 is a repeating decimal. So do not change that to a decimal. It's not going to work. You're not going to get the right answer if you change it to a decimal. Okay, so now to find our vertex, I'm going to take negative 1/3 and plug it in. So we've got 3 times negative 1/3 squared plus 2 times negative 1/3. Now, I dislike fractions as much as you do. I can do this by hand, but let's talk about how we can use the calculator to make our lives a little bit easier. So take your calculator. Let me clear this a little bit so I have a fresh start, okay? So I'm going to type it in as is. I've got 3 parentheses, negative 1/3. I mean, this just makes it so much easier. Make sure we're using parentheses there, plus 2 times, and again, I'm going to go ahead and use parentheses because I want to make sure we get that negative in there and I do everything correctly. And let's see what we get. Boom, negative 1/3. So see, that wasn't so bad. We could use our own brains to get that, but your calculator can help you with those more difficult ones. So, and I should have put y equals. So the y value is negative 1/3, and that means that the vertex is negative 1/3, negative 1/3. So really important to me, 2 things that you make sure you're doing correctly. We're writing our axis of symmetry as an equation, x equals, and make sure that we're writing our vertex as a coordinate.